All right, you guys, this is our last section. That should make you so happy. And it should make you happy because we get to do law of cosines, which is awesome. So, without further ado, let's rock the socks off this thing. Law of cosines. So remember we talked about law of sines, there's a couple of different situations. Law of cosines is when you don't have anything matching. So it's a side, angle, side, or side, side, side. By matching, I'm talking about angle to side matching. All right, so if you don't have any angles to side matching to set up those law of sines proportions, that is when we use law of cosines. So you start off with your law of sines if possible, but if you can't pull that off, then you go to law of cosines. Okay? All right, so in triangle ABC, with sides ABC, of course, this is what happens for our law of cosines. A squared is equal to B squared plus C squared minus 2BC cosine A. Now, it looks freakier than what it is. The rest of them are all the same pattern. The moral of this story is, if you know cosine of A, so you know either one angle, if you have it right. If not, you can find it pretty easy. And then you know the other two sides. And then that one angle. Nothing matches up over here. Your angle and your side are the same, or that's the matchup. All right? Okay, and then all the rest of them just fall in suit. So if I have B squared, then I know I have A and C minus 2AC cosine B. Right? C squared is equal to the other two, A squared, B squared. And then you go from there. All right? Okay, so let's do this thing. So let's look here at example 1. I'm going to find A in this given triangle. Find A in the triangle. So here's what the book has for my triangle. I'm going to scoot this up just a little bit. So here's my triangle. I know this is A, B, C. B here is 5.0. A, of course, is across from that. C is equal to 11. And angle A is 52 degrees. All right? Side, angle, side. I don't have any matches. I don't know what C is, and I can't figure it out because I don't know what B is, right? So my angles are out. That's where you have to step in and go ahead and use our law of cosines. Okay, so let's do it. I'm going to find A, so I'm going to use a formula. A squared is equal to B squared plus C squared minus 2BC cosine of A. And then fill in what you know. A squared, so side B here is 5. C is 11 minus 2 times 5 times 11. And the cosine of 52. Now here's the kicker. I am looking for the side of a triangle. When I take the square root of this, is that going to be any possible way for it to be negative? No, because it's a side. It's an actual legitimate value that I'm going for. You can, in my opinion, take the square root and put all that stuff underneath there, or you can figure it out. Your choice before you square root that. So you get 78.28, and then you square root both sides. A is now equal to an 8.85. Go back and look at your digits. Each one of them has 2 digits, so that's all you can have over here. A is 8.9. There was no units on it, so that's it. A is 8.9. If you don't have anything to match up, you are simply going to be using cosine. And you just solve for the other one. All right? Okay, let's try this one. I'm going to scoot this up a little bit here. So example 2 is finding this distance here. I'm going to make this a little bit bigger. Okay. Law of cosines. Side angle side again. A surveyor wishes to find the distance between 2 points A and B. So on these other sides of this, looks like a lake of some kind. Oh yeah, there it even says it. Good call. While standing at point C, she finds AC to be 259 meters, BC to be 423 meters, and angle ACB to be 132 degrees 40 minutes. See figure 12, that's all laid out. I want to find the distance here, AB, to the nearest meter. So this works out great because I don't have a right triangle, right? So that's the whole purpose of these law of cosines and law of sines, is when you don't have these nice right triangles, you can still do these oblique triangles here. I have this side, this angle, and this side. No matchups. But I want to know across from C here. So I'm just going to call this side C. C is equal to that AB segment. Okay, so I'm going to look at this and say, okay, what is my side C? So I have C squared is equal to my other two, 259 plus 423 squared minus 2 times those multiplied, and the cosine of the angle that I actually know. All right. Now, C squared is equal to, you can plug all of that into your calculator, or you can literally just square root and put all of that into your calculator. Do you see what I mean? Like I could at this point just say, okay, I'm going to square root this and square root that. If you're plugging it all the way into your calculator, you can do it at that point. Either way. I'm going to take those off just so that you can see. What do we get? 394,510.6 is what I got. Now, if you square root both of those, you know it has to be positive. I'm looking at 628 and then meters.